Hello, I am doing another Biotic pump video, and I just want to do an alternative thoughts on what clouds are doing in the sky. So I'm doing this because people haven't really described it this way in what literature I have seen about cloud formation. But anyway, if you imagine a cloud, it contains water droplets and they're going down. And in relation to the air droplets, or the air particles. So the water droplets are going down and the air is going up. And when a cloud condenses, a bunch of heat is given off. So it's like when you boil water, you absorb heat, and when it condenses, heat is given off. And there's always been an issue about our clouds expanding by getting bigger, or they expanding on the edges by a kind of a contraction that's happening as water vapor turns into droplets. So anyway, I'm going to try and explain how a cloud could be an air pump and a countercurrent heat exchanger. So first off, when I did cloud in a bottle, a cloud in a bottle only happens when there is reduction in pressure or reduction in temperature. It doesn't happen any other time as far as I can see. So, and it seems to be that the reduction in pressure and temperature are happening together. So that means there's a slight problem here, because when the water water vapor condenses, there's heat given off. So that should mean that it's expanding, but it can't be expanding, and this area cannot expand into an area with water vapor in it and make the water vapor condense. So how can clouds get bigger in such a situation? And this is how I'm going to show it. So the droplets are falling down and the air is going up through the droplets, and this relative movement must take place. So it might only be a centimeter, or it might be 60 centimeters per minute or something like that. It can be slow, and the bigger the droplets, the faster they come down. So now, how can you see that as an air pump? So you can imagine air down here passes into the cloud. So this air contains water vapor. All the air around this cloud contains water vapor, and maybe the same amount of water vapor, maybe even more. And so this air goes up through the cloud, it passes the droplets of water, and as it goes up, it expands, and as the water doesn't contract or anything, but air rising expands. So it's expanding as it goes up, and that means it's going to end up being saturated with water vapor as it comes out through the edge of the cloud. Now, when it comes out through the edge of the cloud, it doesn't have any droplets in it anymore, and the droplets going down in the air going up means that this air that finally comes out at the top is warm and it's saturated, and so it will, being warm, being saturated with water vapor, so water vapor's molecular weight is 18, and dry air's molecular weight is about 29. So as soon as it comes out here, saturated with water vapor, and it's finally away from being impeded in its upward motion by the droplets, it will speed up. So if it was going this fast here, it will be going this fast up here at the top. And if it's speeding up, that means it's this air here, the pressure is dropping. And if the pressure is dropping, you're going to get condensation. So the condensation isn't from the rising pressure from the cloud, it's from the falling pressure from the cloud. And also, if you're getting condensation here and heat being made here, you are also going to get the counter current heat exchanger. So the heat is going to be mostly impacted on. So what you're doing is you're getting moist air is going up through the cloud. Its moisture is being removed in the heat exchanger, and it comes out of the top of the cloud dry. So because as it comes out the top, more droplets are being produced, and if it's coming out the top of the cloud dry, because we only see the water vapor, we don't see that the cloud is pumping warm air up into the upper atmosphere. And meanwhile, at the bottom of the cloud, so what's happening at the bottom of the cloud? Could it be that so the cloud is warm because of the condensation, so the cloud is potentially rising. So if the cloud is rising, that means it is also stretching the air here. Or like if the cloud is rising away from the air underneath, and if it's, as I said, it's a heat exchanger, it's bringing the warmth to the top. That means the water coming down here, the moisture coming down here through the falling, so the moisture is falling down slowly, and heat is going up, just a heat exchanger. This means that the air at the bottom of the cloud is going to be cooler, and cool air means more condensation too. So you're getting condensation happening at the top of the cloud and at the bottom of the cloud, and you're getting air is being sucked up and dried by the cloud itself. And this is my first attempt at explaining it, but I think when you look at the cloud videos, you're going to see that that's actually what is happening.